Hello wonderful person, this is Anton, and in this video we're going to be talking about a discovery of a very unusual galaxy that has not one, not two, but three supermassive black holes that are all very active and are spewing out a lot of energy. We'll also talk about some other discoveries that pertain to this and why it's sort of important to understand. Anyway, let's talk about this and welcome to What the Math. So by now you probably are aware of the ultra interesting and super cool supermassive black hole picture that we took roughly around 2 to 3 years ago from when I'm making this video, that was analyzed for about 2 years and whose data was finally released to the public in April of 2019. I'm obviously talking about the M87 picture that you see right here. But there are a lot of other less recognized and less known pictures that we've taken of various objects out there in the universe that also deserve credit. And today I wanted to talk about a very unusual galaxy that we recently discovered in some of the data from a telescope known as Chandra. The pictures from which showed us not only some really cool galaxies, but also galaxies that possess 2 black holes and several galaxies that possess 3 black holes. Now, at least one of them was very thoroughly studied afterwards, and we'll talk briefly about this particular study as well. Now, first of all, the pictures are not super high quality. As a matter of fact, most of these are because the galaxies are really far away and only one telescope was taking these photos. But as you can see here, what all of these photos show us are the galaxies with 2 or 3 different supermassive black holes on the inside. And in most cases, this is because of the phenomenon known as the galactic collision, where 2 galaxies merge together, and through the merger, they basically form this union, kind of like this. And what we're looking at is literally the merger itself, the process of merger, with 2 supermassive black holes somewhere on the inside there. And normally, because of all of this merger, very large amounts of dust and various matter start falling inside the black hole, thus activating it, turning it into what's known as AGN, or active galactic nuclei. Now this black hole right here, this is the one in the center of our own galaxy, is not an AGN, it's not an active galaxy. Our black hole for the most part is pretty quiet and pretty inactive. However, the M87 black hole is part of an extremely active galaxy with a very long astrophysical jet that's been created by the black hole itself. But in case of these galaxies, many of these have 2 or 3 of such black holes, creating tremendous amounts of energy. And in this particular study, the scientists behind this paper studied one of these merging galaxies to discover and to analyze 3 very active black holes in the middle. And this is sort of what they've discovered. So there's this galaxy that has a pretty peculiar shape, with potentially one galaxy being here, one being here, and one being right here. And despite a somewhat unusual shape to begin with, what's even more unusual is that there are these 3 really active spots that represent the very active galactic nuclei. So this galaxy has 3 galactic nuclei, and all 3 are spewing out a lot of energy and are creating these really powerful astrophysical jets. Now, I tried to create this in Universe Sandbox, and this is just a simulation. We don't really know where the jets are pointing, but it probably resembles something like this, with 3 really powerful, very active astrophysical jets pointing away from the galaxy and creating this somewhat unusual shape with literally 3 lighthouse-like formations that create very powerful, very energetic jets that are also most likely preventing any star formations in the entire galaxy, creating a very strong galactic wind that's making the galaxy lose a lot of mass. Now, generally speaking, these double and triple AGN galaxies are ultra rare, but it's very interesting for us to study because this is literally how pretty much all of the galaxies in the universe evolved. Our own galaxy, the Milky Way, most likely also experienced this and absorbed other galaxies, combining their black holes and their matter into our own galaxy. And it's also very likely that at some point maybe the Milky Way also was an AGN with as much interesting activity and just as much energy being created by these black holes. But there is one mystery, however, and the mystery is that we don't seem to see these very often. As a matter of fact, they're almost non-existent, and in this particular study we've only discovered 2 confirmed triple AGNs, basically galaxies with 3 black holes. Now, why is it that most galaxies don't seem to have double or triple black holes? The scientists actually can't really answer this just yet, because we don't really understand whether they're just too rare and they don't happen very often, or if somehow these black holes merge. Now, if they actually merge and if they become a single super ultramassive black hole, this is where it gets kind of interesting, because today scientists believe that it's possible for supermassive black holes to never collide. It's known as the final parsec problem and refers to the idea that even though 2 regular black holes can collide quite easily, especially because the gravitational waves make them lose energy and thus collide with each other, the supermassive black holes don't have the same property. Basically, because they're so massive and so large, at some point, at a distance of about 3 to 4 light years, they reach a point where there's nothing between them anymore, and there's almost no way for them to lose more energy and to come closer. So they kind of become stuck in this perpetual motion around each other and can theoretically never really collide, or it just takes a really long time. For this reason, most scientists today sort of predict that there should be a lot of these dual black holes, but we don't see that. So somehow the black holes find a way to collide, but we don't understand how. And by seeing a lot of singular black holes but pretty much no dual black holes, when obviously very few triple black holes, we now realize that they do find a way to either collide or somehow remove one of the black holes, and we don't really know how that happens just yet. In other words, instead of really calling it the final parsec problem, I think a much better way would be the missing black hole problem, which kind of refers to the idea that, well, okay, it seems that these black holes either collide or disappear somewhere, because for the most part, pretty much most major galaxies out there only have one single black hole in them. Now, I guess another interesting question is, well, what's going to eventually happen to these triple black holes in this unusual galaxy? And according to the scientists behind the study, we expect that in about 2 billion years or so, they will come close enough together to establish a kind of a triple system or triple black hole system. And that's because the one in the middle is a lot more massive than the other 2 black holes. I'm going to show you how massive they are in a few seconds. But essentially they'll possibly create a system with one central black hole and these 2 smaller black holes orbiting around the central black hole, literally creating a kind of a planetary system but with really massive black holes. Now, the most massive black hole in this particular galaxy is roughly around 31 million masses of the Sun. That's around 8 to 9 times more massive than the one in our own galaxy, Sagittarius A star, and in comparison, in at least size comparison, this is kind of what they look like next to each other. So this is our own black hole, that's the black hole in that triple galaxy far away. And if you were to place Earth here, you would most likely feel extremely insignificant in comparison, because basically the size of this really massive black hole next to it is absolutely tremendous. The radius of this black hole is about 0.6 to 0.7 astronomical units, which is about the distance of Venus to the Sun. Now, what about the other 2 black holes? Well, all 3 roughly look something like this. The second black hole is about 2.5 million masses of the Sun, and the third black hole is around 5 million masses of the Sun. So these 2 galaxies are relatively similar to the one we have in the middle of our own galaxy. And if I were to basically run the simulation here just to show you what all of this looks like, you'll notice that they can kind of orbit around the central very massive black hole and will most likely not really fall into it. So, oh, never mind, they're actually going to collide together. So all in all, we think that eventually this will evolve into some sort of a really interesting, very unusual galaxy, but we don't really know, and it's just going to take too long for us to wait and see what happens. But there's a chance that we might see something that does look like the end result of all of this. We just have to try to look around and find more galaxies out there. And one of the more important suggestions from this particular paper is that we think that it's very likely that this is kind of how the M87 galaxy was formed. Today we believe that the ultramassive black hole that we were able to take a photo of right here is the result of merger of several black holes from possibly a triple black hole system. And one of the main reasons for believing this is because of the shape of the actual galaxy. Because unlike our own Milky Way, M87 is actually not a galaxy with a regular shape. It's what's known as an elliptical galaxy, but with a very unusual shape that doesn't really make much sense. So it sort of looks like a result of a very large collision between several galaxies where many black holes spend a lot of time mixing various matter and various stars on the inside, resulting in this very cool looking, but at the same time very massive, very bright, and extremely large galaxy known as M87. It's actually one of the largest galaxies and definitely the most massive galaxies in the vicinity of our own local cluster, and the only explanation for its existence is that it possibly experienced this very large collision where triple black holes did exist previously. And if this is how this galaxy was born, then it's also very likely that the largest galaxy ever discovered, IC1101, was also born from these multi-black hole collisions. So there is a possibility that this photo right here is actually a kind of a precursor to the formation of these extremely large, very, very bright elliptical galaxies that we've found pretty much everywhere in the universe. Anyway, on that note, once we learn more, I'll make sure to do a follow-up and talk a little bit more about this particular topic of galactic collisions and also black hole collisions. For now though, that's really it. If you'd like to learn more, check out the paper in the description below, but for now that's really it. Thank you so much for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and come back tomorrow to learn something you may have not known before. I'll see you tomorrow, space out, and as always, bye bye.